This video is going to address the specifics behind our triangle similarity theorems. Last video we looked at similarity and said that it requires us to have three congruent angles that correspond with each other and three proportional sides that correspond with each other, at least for the triangles. Now, with our triangle similarity theorems, this allows us to not have to show that all six of those parts are either congruent or proportional. With our triangle similarity theorems, we can kind of just look at a few parts, and if those parts they match up how we need them to match up, then we're good to go to prove two triangles are similar. So we've got three of those. We have the angle-angle similarity theorem. We have the side-side-side similarity theorem. And we have the side-angle-side similarity theorem. Okay, so we'll go ahead and go through the three of these, say what are the requirements of those, and then also draw a picture before we go ahead and ask some questions on those. So the first one we're going to look at is the angle-angle similarity theorem. So what that means is that we have two pairs of corresponding congruent angles. Okay, two pairs of corresponding congruent angles. This tells us then that the two triangles are similar. Okay, so let's draw a picture. Let's draw a triangle here. We've got A, B, and C. We've got triangle D, E, and F. Okay, so we've got one mark on A, one mark on D, two on B, two on E. So this tells us that angle A and angle D are congruent because they both have that single marking. Angle B and angle E are congruent because they both have the double marking. And what that means is that all of our angles are actually going to be congruent. Because even though we don't know angle C and angle F, we do know that each triangle will always have 180 degrees. If we know two of those angle measures, we know that the third as well. That's going to then mean that angle C is in fact congruent to angle F. So we have triangle ABC is similar to triangle DEF by angle-angle similarity. Oh, there you go, by angle-angle similarity. So if I was making a proof, finishing up my proof, I would end it with triangle ABC similar to triangle DEF by angle-angle similarity. Our next theorem is side-side-side similarity theorem. This means we have three pairs of corresponding proportional sides. Okay? The two triangles are similar. So let's go ahead and look at a picture. So A, B, C, D, E, F. Okay, now let's see. I'll go put some numbers on these ones. We'll go 1, 3, and 3, 2, 6, and 6. Okay, now what we can kind of tell here already is that A, B to D, E is 1 times 2 is 2, 3 times 2 is 6, 3 times 2 is 6. So that tells us that the corresponding proportional sides are proportional. Now, what I need to make sure I'm specific with here is that AB matches up with DE. Okay, because AB cannot match up with EF. because AB times 6 gets me EF, but BC times 2 gets me DF. Okay, so my order matters here. So I've got to say that triangle ABC is similar to triangle DEF by side, side, side similarity. Okay, so that's our second one. We've got those corresponding proportional sides. Now our last triangle similarity theorem is side angle side. So we have two pairs of corresponding proportional sides. Okay. And then we have one pair of corresponding congruent angles between the two pairs of sides. Okay, so that's important here. The angle can't be outside that pair, it has to be in that pair. So here we'll have triangle A, B, and C, triangle D, E, and F. Let's go ahead and label our triangle. Here we've got 2, and we've got 5, we've got 6, we've got 15, and we know that B and E are congruent. Okay, so we've got 2 times 3 gives us 6. 5 times 3 gives us 15. So those two pairs of sides are proportional and they correspond. And then angle B and angle E are congruent. So we've got our side, angle, side, side, angle, side. So we can make our similarity statement of triangle ABC is similar to triangle DEF by side, angle, side similarity. Okay, now you've got a few questions to answer that will ask you to identify why two triangles are similar at the end of this video.